Hey guys, David Sleeper here. Wanted to go over this little sign distance function, Chromium embedded framework with a reflection editor I've kind of been working on here. So the CEF part, the Chromium embedded framework, is running a web page, and I'm tossing a little DX12 child window in it. So the actual application itself is a native C++ DX12 inside kind of this little browser window in a way. So the things I wanted to go over here kind of are threefold. One, a great little reflection library I've been playing with that I've liked a lot is RTTR. It's kind of one of the best C++ reflections, the cleanest ones I've seen out there. And mixing that with CEF and JavaScript really allows you kind of have these uh, really quick, reflection capabilities into your software. And now the other one I want to go over is just this really cool new kind of form of rasterization that's been coming up. Shader Toy has some great examples, but yeah. So here's kind of an example of an editor. So I'm writing the sign distance functions also to the depth buffer. So this gizmo is in fact a renderer, just a traditional triangle mesh, but the sphere itself is a sign distance function. So here I'll go ahead and add another sphere, and I'll show you, if you haven't seen these, why they can be pretty darn cool. So two spheres. Even though these things are pixel perfect, you can get pretty darn close with just triangles. So these things are zero triangles. It's just rendering with pure math. But where it gets pretty crazy is the ability for these shapes to affect other shapes into smooth. So let me go ahead and set the blend factor to 10. Selected the wrong shape. So now that this blend factor is 10, you can see this stuff is pretty, to do this with triangles in real time like this is, I mean, it's just, it would be nearly impossible to have this kind of this real-time behavior. But what this lets us kind of do is kind of see how these things can work together. You can even subtract these shapes. So see how I just squished that, and let's go do an intersection. I guess it's not intersecting much, but intersection's not super great for smoothing here. Let me set the blend factor to 1, but there you go. Now you see a nice crazy intersection of these spheres. So back to add, let's make them smooth. Now here, let me expand this even more. Oops, that's a little much. So now we have almost like a little ellipse. There's also different ways where you could use a math to make ellipses themselves, but this is kind of showing you how even with smoothing or other options, you can make lots of different shapes even off two primitives. So in this example, I only have a square, sphere, and the group itself. So the group kind of splits up these sign distance function draws. But let me go ahead and add a little box now. So here you have a little box. Let's go ahead and squish it. I'm kind of, I'll make a little visor maybe. Maybe this will be a little helmeted man. We'll push it forward a little bit. So now maybe we can even add a little bit of smoothing so it looks like it's part of it. There you go. So what it's doing here, yeah, just all math. You'd have to look at the code and the examples to kind of understand it, but the functions themselves just return a depth, and based on the depth from any point that you give it. And so with that and a feature called ray marching, you can kind of extrapolate both the normals and all kinds of information on how these shapes interact. But yeah, and so that's basically where I'm at with this little work in progress editor. I want to add some more custom rasterization tricks and maybe expand on this, but let me change the color of the helmet. Let's give him a little red helmet. It's a little pink. But, oh, yes. But yeah, so just that's the idea, playing with a little bit of custom rasterization tricks and the editor. So all this code's available. It has the examples of kind of how it does the reflection, how it calls JavaScript, how it uses CEF, and a little bit of DX12. The DX12 portion, of course, is very work in progress because I'm mostly just rendering these simple shapes. But yeah, that's where I'm at now, but very cool stuff.